Hi everyone, welcome back to another video for this more concept series. And today I will be going through with you guys about dilution and acid-base reaction. And also just to sidetrack a bit, I finally got my cursor working because I realized that I can see my cursor moving on my screen, but when on my screen record it doesn't move. Yeah, but I just got it fixed. Yeah, so yeah, quite happy about that. So the reason why I decided to group these two together is because although they are different ideas, but they are usually go hand in hand in terms of in questions and also in calculations and also in your practical. So here I have a definition, not definition, but an explanation of dilution. You can read it and attempt to understand. If you don't, it's okay. I'll be going through some diagrams with you later on. So this dilution is the addition of more solvent, and your solvent is usually water, and the number of moles of solute does not change. This is very important. But the solute is now dispersed in a larger final volume, hence resulting in a lower concentration. So what the heck does this mean? So I have a very simple illustration. So let's say I have a beaker, right? And then I top it up with 1 dm cube water. And then I add 1 mole of salt. Anyway, some random salt. So what's my concentration here? 1 mole over 1 dm cube. So my concentration is 1 mole per dm cube. Right? But let's say I add another dm cube water. So now I have 2 dm cube of water, and I still have 1 mole of salt. What's my new concentration? 1 mole over 2 dm cube is 0.5 mole per dm cube. So from here you can see that I'm just adding solvent. This is your solvent. This is your solvent. This is your solvent. The solvent increase, right? But my number of salt, my amount of salt is constant. I'm not adding any more salt into a solution. I'm just adding water. So you can see that the number of moles of salt is constant, 1 mole to 1 mole, but my concentration has dropped by half. So this is a very important idea to remember. When you add more solvent, you are diluting it, so the concentration will decrease. But your number of moles of salt is still constant. You're not adding any more salt to it. So I know that many of you have come across this equation called C1V1 equal to C2V2 earlier on, and it's a useful formula, but I just want to emphasize this understanding to remember that your number of moles of solute does not change. It is important to keep in mind as you go through doing your dilutions and so on, and doing calculations in both your theory and your practical. Yeah, so moving on to acid base, I don't have much to highlight because acid base should already be a very familiar reaction for most of you guys. And the only two things that I want to highlight is that these are the two indicators that you guys should remember, because in your A level you will come across like 6, even 10 different indicators, and if you don't know which one to memorize, just memorize these two because they are very commonly used. You definitely will see them in your A level practical, in doing your practical lessons, and sometimes theory and practical people they will ask you suggest an indicator, suggest a suitable indicator, and state the color change. So red or yellow, orange colors, blue, pink, red. So if you guys don't know what to remember, just remember these two, and you have listed the stats here, the numbers here for you guys. So now moving on to the first question. So here's a two simple questions that I've come up with my own, and please pause this video and attempt it, or at least read it if you guys can. And after you have done it, you can resume the video. So we'll come back. I hope you have attempted the questions. So now I will show you guys how I go through it. And it can be a bit lengthy, but once you get a hang of it, it can be done with just a calculator without pen and paper. Okay, so for A, you have 25 cm cube of hydrochloric solutions of 1 mole per dm cube concentration, and it's topped up with water, your solvent, until 100 cm cube. Calculate the concentration of the final solution. So your final solution here is your 100 cm cube. So for A, you calculate how many moles of HCl you have in 25 cm cube first. And you know that you want dm cube based on the concentration, you have 1 mole, right? So you multiply by 25.0 over 1000, and then you get 0.02 by 0 mole. And in case you are rusty, what I'm doing here is that 1 dm cube is equal to 1000 cm cube. Sorry, so by dividing by 1000, you are finding how many moles of HCl are there in 1 cm cube. And then when you multiply by 1 times 25, you're finding how many moles are there in 25, 0.0 cm cube. So now the NHCl is constant, right? So your NHCl in 25.0 cm cube is equal to the number of mole of HCl in 100 cm cube as well. If you guys don't understand, please go back to rewind the video and go back to my explanation earlier. The number of moles solute is constant. Only the concentration changes, and that's what we are calculating here. So now you can move on. Final concentration. Since the number of moles is constant, is 0.0250 multiplied by 1000 over 100, you get 0.50 mole per dm cube. Alright, so now in case you guys are rusty, here you are dividing by 100 to find number of mole in 1 cm cube, and then by multiply by 1000, you're finding number of mole in 1 dm cube. Right? Now, for question B, it's more of a practical problem that I think is interesting for you guys to think about, because this kind of dilution is more common for biology students, and I know not everyone here takes biology, so just want to prompt your thinking head. So you see here, I am asking you to get a solution of 10 to the power negative 3 mole per dm cube concentration from a solution of 1 mole per dm cube. And you see this, it actually 10 to the power 3 times dilution. So how do you go about doing it? One definite way is to take 1 cm cube. Let me switch back to blue actually. One obvious way is to take 1 cm cube of the 1 mole per dm cube solution, and you add it to 1000 cm cube of water, right? Because near to here is basically 10 to the power 3 times, right? Yeah, sorry, it's actually not 1000, it should actually be 999. So your final volume should be 1000. Okay, this works, but the issue here that you may see is that you need a huge beaker. You need a huge beaker of 1 liter capacity. Actually, might need more than 1 liter because if not, you quite quick just at the brim here. So how do you go about doing this? So you guys can do something that is called serial dilution. So from 1 cm cube of 1 m, you add 9 cm cube of water, and then you label this as Fa1, and then you take 1 cm cube of Fa1, you add another 9 cm cube of water, and then become your Fa2. And then from here, you take out another 1 cm cube of Fa2, and then you add another 9 cm cube of water, and this becomes your Fa3. So what you are doing here, okay, my video got cut off halfway, it was quite weird, but so what you're doing here is that you are diluting it by 10 times once, and you're diluting it by 10 times once more, you're diluting it by another 10 times one more time. So you're actually diluting it by 10 to the power of 3 relative to the initial solution. And by doing this step, all you need is a measuring cylinder. So I hope this video has been helpful and that you guys have learned something from this video, and really thank you for watching until now. So